Hello and welcome to this new video. In the previous videos, we implemented the map selection system and the server travel system when starting the match. Today, we want to optimize our code in a way to avoid duplicates every time we want to create a new game mode and a new player controller. For example, we don't want to copy and paste what we did in the game mode and the player controller of the lobby every time we want to manage sessions in another game mode or player controller. So, we want that we will have a common part in our game, which is independent of a game mode or a player controller, and which will be callable from any game mode or player controller to manage sessions. First of all, uncheck the absolute box when doing a seamless travel. In the case of a seamless travel, the travel must be relative. Also, connect the destroyed event, because in a seamless travel the lobby game mode is not destroyed. The first optimization I want to do is to change the script that checks if the connected player controller is ready or not. For now, we use a timer that calls a function that checks the state of the connected player's controllers. It's not a good solution. We'll do it in another more optimized way. Currently, we can know the readiness status of a player controller from a Boolean variable, which sets to true when the set player card event finishes execution. Go to your lobby player controller. You see that most of the events can be the same if we want to add a new player controller. For example, if in World 1 a client wants to leave the session, he must call the leave session event of the player controller of World 1. For that, we want to start moving these events into an object independent of a level or a controller. The solution is therefore to create a player controller that will be the parent of all the player controllers of the game. This parent can implement these events. Like that, a child player controller can simply call the event of the parent instead of implementing the same event in the player controller of the level. So go to the main menu folder and add a new blueprint class of type player controller. Once created, name it master player controller. This will be the parent player controller. Go back to the lobby player controller, then reparent this class so that its parent will be the master player controller that we just created. In the master player controller, add an event dispatcher and name it on player controller ready. This will be an event to call when the player controller is ready. We now want that the lobby controller interface to be an interface specific for the master controller. This allows us to avoid creating a specific interface for each player controller later. To do this, search for the lobby player controller interface and rename it b_master controller, then move it to the main menu folder. Create a new folder and name it Master Player Controller, then move the interface and the Master Player Controller into it. Now go back to the master player controller and implement the interface. If you go back to the lobby player controller, then you will no longer see the events of the interface. This is normal because they are now in the parent class. On the other hand, you see the functions that return values. But now with the override symbol. That is to say that these functions override the functions of the parent interface. Similarly, the events of the interface implemented in the lobby player controller override the events of the parent class. So, what you have to understand, a child player controller can implement the interface. In this case, its implementation will be executed by override, and therefore the implementation of the parent will not be taken into account. On the other hand, if the child player controller does not override the interface, then the implementation of the parent will be executed. Now we want to move the implementations of the lobby player controller that may be common to the parent class. The first thing to move is the event set player card, which can be an event usable by all player controllers. So we have to move the common variables, so the player cards and the is player controller ready. You can copy then paste into the master class, and you can also simply right-click on the variable, then click on Move to Parent. You therefore notice that the lobby player controller has changed the names of the variables. This is normal, because we cannot have the same variable name for both parent and child. In the parent class, implement the getPlayerReadiness function. Now remove these variables and use the parents instead. I'm not going to update the value of the isPlayerControllerReady variable, because I want to change the way of this check later. Select the implementation of the setPlayer card and paste it into the parent class. It can now be removed from the player controller of the lobby. The event called in on possess of the lobby controller is now a call to a parent event. We will not touch the setup UI implementation, because it is a thing specific to the child class. Each level has its own UI. Now we want to do the same for the implementation of the register player in session. Do the same for other implementations that handle sessions. Just follow me. I want to update the value of the isPlayerReady variable before moving it. For now, implement the isPlayerControllerReady function in the parent class. We will change that later. Then, implement the getPlayerCard function. Check that everything is implemented in the parent class. Now go to the Master Controller interface. Add a new function and name it getMasterControllerReference. This function is used to return a reference of the player controller of type MasterPlayerController. We will see its use later. Go back to the MasterPlayerController class and implement the function. Remove these overridden functions in the lobby controller. You can override the getMasterControllerReference function to return the child reference. Anyway, the parent class returns it without needing an override. The same for other functions. This is just to show you how to override a function if needed. Go back to the interface and delete the Get Controller Readiness function. We no longer need it. We want to make a more optimized implementation. So also remove the variable is player controller ready. Now go to the lobby game mode. We want to change our way of checking if the connected player controller is ready or not. The error you see is normal, because we removed a function from the interface that is used by the game mode. Disconnect the timer. We will delete it later. To know a connected player controller is ready or not, we will bind the event dispatcher that we created in the master player controller. This event is triggered when the player controller is ready, and therefore the bind will be executed in the game mode. And here we see the usefulness of the Get Master Controller Reference function that we added and implemented. Because we cannot bind the dispatcher events of the master player controller without having a reference to the class of its type. Now you can assign the event on player controller ready in the game mode. When this event triggers, you will be able to implement the logic in game mode to get the player card and spawn the character. Make sure to return the correct variables when overriding in the lobby player controller. This is just to show you how to override. I will remove these functions later because the parent class does the job. I removed the overrides. I just want to leave the override of the class reference. In the lobby game mode, go to the Check for Controller Readiness function and delete the invalid node. Now we want to implement the logic when the connected player controller is ready. From the Master Player Controller reference, assign the event on Player Controller Ready. Back in the Master Player Controller, we must add a parameter to the event dispatcher which represents the player controller which triggered the event. Return to Lobby Player Controller and trigger the event when the onPossess event finishes execution. In game mode, go to the Check for Controller Readiness function. Delete the loop. Rename the function to be f_on_player_controller_ready. Call the function when the event is triggered. Then add a parameter to this function of type controller, which represents the source player controller that triggered the event. Connect the pins. We must now delete the timer and its associated variable. We still have one thing to fix. In fact, with this implementation in the Lobby Player Controller, the call of the event dispatcher will be executed before the onPossess finishes the execution of all the events. So we must check that everything is good before making the call. In case of Lobby Player Controller, it will be ready when the player card variable is updated. So what I want to do is add a timer on event begin play, which waits for the variable to be valid. Once valid, We will call the event dispatcher. Add a new function in the lobby player controller and name it f_is_player_card_set. This function will call the event once the variable is valid. To check that the player card variable is valid, simply check that the user ID is not empty. Add the timer in the begin play event and promote its output to variable so we can clear it. Remove the call node at the end of onPossess event. Go back into the function and add the call if the variable is valid. Clear and invalidate the timer after the call. Normally everything is good. Run a test to check. And here it is. The player controller readiness system works fine. I want to create a session and join it from player 2 to check the implementation of the master player controller. Here it is. Everything works as it should. That's all for this video. See you in the next one.